In this question, we're told when ax cubed plus 13x squared minus 10x minus 24 is divided by x plus 3, the remainder is minus 39. We're told to write down an equation satisfied by a and hence show that a is equal to 6. So in this question, essentially we're told that when it's divided by x plus 3, the remainder is minus 39. So what we're told is that by the remainder theorem, that f of negative of this term, so f of minus 3, that will be equal to minus 39. So I'm now going to substitute minus 3 into our polynomial. So I'll get a times minus 3 cubed plus 13 lots of minus 3 squared minus 10 lots of minus 3 minus 24, and by the remainder theorem I know that this is equal to minus 39. So minus 3 cubed is minus 27a. Minus 3 squared is 9 times 13 gives me 117. Minus 10 times minus 3 is plus 30 minus 24 equal to minus 39. So tidying up the left hand side, I get 147 take away 24 gives 123 minus 27a is equal to minus 39. So if I add 39 to both sides and add 27a to both sides, we get that 162 is equal to 27a. And so finally, if I divide by 27, we get that a is equal to 6 as required. Okay, so let's have a look at part B. Part B says to solve the equation 6x cubed plus 13x squared minus 10x minus 24 equals 0. So initially we're going to have to use the factor theorem and trial and error to find an x value that we can substitute into this equation so that it evaluates to give us 0. What we need to do is try factors of 24. Now factors of 24, there's quite a few, so you get 1 times 24, 2 times 12, 3 times 8, 4 times 6. These are all factors of 24. So start with the lowest one. We can do plus or minus 1. Now I can tell by putting plus or minus 1 in here, since 3 of the terms are even and 1 is odd, these are never going to sum in any way by putting a value of 1 into there to give 0. So I'm going to start with 2. So I'm going to evaluate f of 2. This is going to be equal to 6 lots of 2 cubed plus 13 lots of 2 squared minus 10 lots of 2 minus 24. So this gives f of 2 is equal to 48 plus 13 times 4, which is 52, minus 20 minus 24, which I can see is not equal to 0. So let's try f of minus 2. 6 times minus 2 cubed plus 13 times minus 2 squared minus 10 times minus 2 minus 24. So evaluating this now, we get minus 8 times 6, which gives me minus 48. I get plus 4 times 13, so I get plus 52. Minus 10 times minus 2 gives me plus 20. And we get minus 24 at the end. And on this one, I can see 52 plus 20 is 72, and minus 48 plus minus 24 is minus 72. So f of minus 2 equals 0. Therefore, by factor theorem, what we know is x plus 2 is a factor. So at this point, I know that 6x cubed plus 13x squared minus 10x minus 24 is equal to x plus 2 multiplied some quadratic ax squared plus bx plus c. So what I now have to do is I have to find the coefficients of this quadratic. The way I like to do this is I like to do a table and imagine expanding out this quadratic with the linear factor and comparing coefficients to find my terms. So what I do is I imagine first of all x times ax squared, so whatever would be here is the ax squared. That would give me 6x cubed. So I'm going to fill in the 6x cubed in the table. And so I know x would have to multiply 6x squared in order to get 6x cubed. Now I'm going to finish off this column by multiplying plus 2 by the 6x squared, so I get plus 12x squared. Now actually what I want is 13x squared, so the next term would be an x term, and I get x times x, which gives me an x squared term here. So really all I want in this term here is one extra x squared, so that these add to 13x squared. And so in my quadratic I only need to multiply by a single x. Now if I complete the column again, x plus x times plus 2 gives me plus 2x. Now, just finishing off, I've got plus 2x, but actually I want minus 10x, so that means I'm going to have a minus 12x in this last entry of the row here. So that means the constant I'm going to have in my quadratic to get this result is going to be minus 12. Now if I've done everything correct when I multiply the two constants together, so plus 2 times minus 12, I get minus 24, which should match up to the last term in my cubic, which it does, and I can just do a little double tick to indicate that it appears I've factorised this correctly. So now I know what the quadratic is, I'm going to factorise the quadratic as well. So I'm going to write 6x squared plus x minus 12. 6 times minus 12 is minus 72. Factors that have a difference of 1 are plus 9 times minus 8. So if I split up this middle term, so I get 6x squared plus 9x minus 8x minus 12. Factorising the first two terms, I get 3x squared times 2x plus 3. If I take out minus 4 as a common factor here, I get another 2x plus 3. And so the 2x plus 3 is a common factor. And then the other factor is the coefficients of that term. Let me just adjust this very quickly. So it shouldn't be 3x squared, it should just be 3x. So the coefficients of those two brackets form our other bracket. So what I know now is to solve this equation 6x cubed plus 13x squared minus 10x minus 24. To solve this, I would factorise to get the brackets x plus 2, 2x plus 3, and 3x minus 4. And this would all be equal to 0. So that x plus 2 equals 0, and so x would be equal to minus 2. 2x plus 3 would be equal to 0. So subtract 3 and divide by 2. So that I get x equals minus 3 over 2, and 3x minus 4 equals 0, so add 4 and divide by 3 on both sides, so that we get x equals 4/3. And that is the question completed. So let's go back now and have a look to see how the marks are awarded in this question. In part A, there's a method mark for using f of minus 3 equals minus 39, so that use of the remainder theorem there. And then there's an answer mark once you get to a equals 6 if your argument through this is convincing. In part B, there is a method mark for attempting to find a value of f of some x value equal to 0. There is then an answer mark for finding that x plus 2 is a factor of this cubic. Now when you come to this part here, There is a method mark if you find at least one of the terms, if you could at least just find the 6x squared of your quadratic, and then there is an answer mark should you find the entire quadratic. Finally, there is an answer mark for factorising the cubic fully, and then finally, once you've got all three solutions, you get an answer mark, the final answer mark. Okay, well I hope you was able to follow my solution and that it made sense on how to mark it.